This is section 2-2. We're on page 79. We're going to solve equations using subtraction this time. So we're going to be using the subtraction property of equality. So this is just like the addition except for subtraction. What you subtract from one side, you have to subtract the same amount from the other side to keep the equation true. So if you have something like 10 equals 10, to keep this true, if we subtract a number from one side, we have to do the same to the other. So if we have 10 minus 4 equals 10 minus 4, that stays in balance because we get 6 equals 6. Okay, let's try this in some equations and see how it goes. So if we have, we're on page 80, we're going to solve for a variable. The first one we have is 142 plus d equals 97. So what we're looking for here is what do we need to add or subtract to get 97. So we have 142 plus d equals 97. We want to get this d by itself. So we have a positive 142. So we need to take away 142 from each side to get that d by itself. So what that looks like is 142 plus d minus 142 equals 97 minus 142. And what's really important here to remember is that we can't put that 142 in front of the 97. It can't be 142 minus 97. Because if you remember, we cannot change the order when we're subtracting. So it's important to put the minus 142 after the 97. So back to the left. 142 plus d minus 142. These two 142's cancel out because it ends up being a 0. So on the left we have just plain d. Then we have equals. Now we have a 97 minus 142. And 97 minus 142 gives us negative 45. So d equals negative 45. So then to check it, we'd substitute that negative 45 back into our original equation to see if it works. So let's try that. So we have 142 plus, open paren, negative 45, close, equals 97. Okay, does 142 minus plus a negative 45 equals 97? Yes, it does. It checks. Okay, let's try another one. We have 27 plus k equals 30. This is also on page 80. Okay, so we have 27 plus k equals 30. Now we have this 27. It's a positive 27, and we want to get rid of it from the left side. So let's subtract 27 from each side to get that k by itself. So that looks like 27 plus k minus 27 equals 30 minus 27. On the left, we have 27 minus 27, so we're left with just k equals 30 minus 27, or 3. Now let's plug that back into our original equation and see if k equals 3 is the right answer. So we get 27 plus 3, going in for our k, equals 30. And yes, 27 plus 3 does equal 30, so it checks. The last one we're going to do is negative 12 equals p plus 16. So this time our variable is on the right side, which is just fine. It doesn't have to be on the left. But we still want to get that p by itself. So this one we have a p plus 16. So in order to get that by itself, we need to take away that 16. So let's subtract 16 from each side. So we end up with negative 12 minus 16 equals p plus 16 minus 16. On the left, negative 12 minus 16 would give us a negative 28 equals p plus 16 minus 16, so we're left with just p. So negative 28 equals p. So let's plug that back in. So we have original equation of negative 12 equals p plus 16. So negative 12 equals negative 28 plus 16. Okay, so negative 12 equals, does negative 28 plus 16 equal negative 12? Yes, it does. So this one does check.